In this video, we're going to try and integrate secant cubes of x. So visualize this as one block multiplying another block. Remember, when you differentiate tan of x, you get secant squared of x. So when you look at this, you can if this is exactly the same as this, so you should be able to integrate it easily. So just remember that this block here we can integrate it easily. Now look at this. When you differentiate, secant squared can be written as this. So when you differentiate 1 over cos, you would get this. So just remember that you can easily integrate this. That will then give you tan of x, and you can easily differentiate secant of x. That will then give you this. So going back to here, what I'm trying to say is that this thing here, you can easily differentiate this, and you can easily integrate this, because this thing here is this. If you integrate it, it will give you this, and then this thing here we can easily differentiate it to give us this. Okay, so just bear that in mind. So because we know that you can easily differentiate this, you can easily integrate this, then we should have a hunch that we should use integration by parts. So now let's use integration by parts. So blindly follow this. So if you set this to be u, set this to be v prime, then if u equals this, then u prime equals this, v prime equals this, then normal v would equal this. So basically you integrate it to give you this. Well, now blindly follow this. It's saying get u times v. It's saying get u times v. So that will be secant x tan x, and then minus the integral of, it's saying gets u prime times v. It's saying gets u prime times v. So that will be tan squared x secant x dx. So this whole thing here is basically this. Okay. Now look at this bit here. So here you've got one block multiplying another block here. Remember that when you differentiate tan, there are lots of ways of expressing the answer. One of which is this, the other way is this. So when you differentiate tan of x, there are two ways of expressing the answer. Well, if this is one way and this is the other way, they're actually both the same, but just written differently. So if you look at this, tan squared, if you minus 1 from both sides, you get tan squared of x equals secant squared minus 1. So we can put this into here. Okay, so this thing here will then become this. Will then become this. Now multiply this out. So that will then give you this. That will then give you this. And now let me think. And now this bit here, you can visualize it as this. You can visualize it as this thing. Okay, and then here you got a minus and a minus, that will give you a plus this thing here. So now now that we're here, notice that this block here is exactly the same as this block here. So let's just call this block here what we're trying to find out. Let's say what we're trying to find out is capital I. So this is capital I, and then you minus the exact same thing, which is also capital I. So you can rewrite this as this I thing, which we've used this, we've done this before. Well, anyway, call it I, and then remember also to integrate this. I've done a whole video on this, so you probably have to track down one of the early videos, but we have done this. When you integrate this, it will give you this, and I've tracked down this video if you can't remember this. So here, hang on. So we are currently here. So now add I to both sides. That will then give you 2i, and now and then also this bit here is this thing here. So we can put this into here, that will then give us this, and then add I to both sides, that will then give us this. So we are now here, and now we want I on its own. So you divide both sides by 2, that will then give you this. And remember earlier we said I, normal 1I equals this, remember. So overall our answer would be given by this. Okay.